Today in this video we will discuss some problems related to Young's double slit experiment and that conditions for constructive and destructive interference. Already we discussed in the previous two videos. Okay, so the problems related to those two topics that we will cover today. Okay, so we will start with our first problem. Okay. So two sources of intensity I and 4I are used in an interference experiment. Find the intensity at points where the waves from two sources superimpose with a phase difference 0 and pi. Okay. So here how to find? So the resultant intensity is given by I1 plus I2 plus 2 root I1 I2 cos phi, where phi is the phase difference between the waves. I1 is given, I2 is given, phi is also given. We have to find I. So in first case we can write I is given by I1 is I, I2 is 4I plus 2 root I into 4I cos 0 degree. So 5I plus 2 into 2. 4I square you can write it as, its root will be 2I. So 2 into 2I again it will be 4I. Cos 0 is 1. So 4I. So we will get it as 9I. Okay. So this is first case. And in the second case what you will get? In the second case you can see that same expression. I1 plus I2 plus 2 root I1 I2 cos phi. What's the value of I1? I1 is I, I2 is 4I plus 2 into root of I into 4I cos phi. Value of cos phi is minus 1. So you can write it as 5I minus 4I, which is equal to I. So here you can write intensity. You can write intensity I1, I2 like that you can mention. Otherwise you may think that I is equal to I, or here I is equal to 9I like that you will get. So it is the intensity at that point. Okay. So intensity at that point where phase difference between the waves is 0 degree, it is given by 9I, and intensity at that point where phase difference is pi, it is given by I. Okay. Similarly for any angle, if it is pi by 3 for any angle, you can use the same relation and you can find it. Okay. If intensity is given, you have to use this relation. Okay. And now next we will discuss another problem based on if amplitude is given. Okay. Two plain monochromatic waves propagating in the same direction with amplitudes A and 2A and differing in phase by pi by 3 superpose. Calculate the amplitude of the resultant wave. Okay. So you have to find the resultant wave's amplitude. So amplitude of the resultant wave is given by root of A1 square plus A2 square plus 2A1 A2 cos phi. Okay. So here A1 is given. What is the value of A1? A1 amplitude of the first wave is A and amplitude of the second wave is 2A. 2 into A into 2A into cos pi by 3. You can write A square plus 2A square, you can write 4A square, 4A square plus A square, 5A square plus 4A square into cos pi by 3 is cos 60. Cos 60 is 1 by 2. What you will get? Root 7 into A. Root of 7A square, or you can write the resultant amplitude is given by root 7 into A. So if intensity is given, you have to use the formula I1 plus I2 to root I1 I2 cos phi, and if amplitude you have to find root of A1 square plus A2 square plus 2a1 into cos phi. Okay, we'll proceed to the next problem. In Young's double slit experiment, the intensity of light at a point on the screen where path difference is lambda is k units. Find the intensity at a point where path difference is lambda by 4 and lambda by 2. So how to find? We know the expression for intensity. It is given by I is equal to I1 plus I2 plus 2 root I1 I2 cos phi. So here we can assume in the case of Young's double slit experiment, both waves are having same intensity. So we can write I is equal to I0 plus I0. If I0 is the intensity of the initial wave, we can write 2 into root of I0 square cos phi. Okay, what we can write 2I0 plus 2I0 cos phi, or we can write 2I0 can be taken common, 1 plus cos phi, and 1 plus cos theta can be written as 2 cos square theta by 2. So here we can write 2I0 into 2 cos square phi by 2. Or we can write 4I0 cos square phi by 2. So this is the intensity of the wave. And here what is the condition given? When path difference is lambda, it is k unit. So corresponding to lambda path difference, we can write. Corresponding to lambda path difference, what is the phase difference? Phase difference is 2 pi. How we can say? So when it covers an angle, when it covers an angle 2 pi, the distance travelled will be equal to lambda. So corresponding to lambda path difference, the phase difference is 2 pi. So we can write in that case what is the intensity that is given. It is k. So when if you are substituting when phi is equal to what is that? 2 pi. No. Corresponding to lambda path difference, phase difference is 2 pi. When phi is equal to 2 pi, the intensity is given I is equal to k. So you can substitute here. So what you will get? 4I0 cos square 2 pi by 2. No. Or 4I0 2 pi by 2 you will get pi. Cos pi is minus 1. Minus 1 whole square you can write it as plus 1. So 4I0 is the intensity and that it is given as k. Okay. 4I0 is equal to k. Now what we have to find? We have to find where path difference is lambda by 4. What is the intensity? So the formula of intensity we can write. The first case I1 is equal to 4I0 cos square phi by 2. And we have to find corresponding to lambda. We can write corresponding to lambda. The path difference is 2 pi. Then corresponding to lambda by 4, what is the path difference? This into this by this. No? So 2 pi into lambda by 4 divided by lambda. Lambda will be getting cancelled. 2 pi by 4 which is equal to what you will get? Pi by 4 can be written as pi by 2. No. Okay. Is it clear? Now we have to substitute here. What you will get? Intensity in this formula you can substitute. I1 is equal to 4I0 cos square pi by 2. Pi by 2 by 2. So what you will get? Divided by 2 which is equal to pi by 4. So 4I0, you can write here itself, 4I0 cos square pi by 4, 4 I0, cos pi by 4 is 1 by root 2. So 1 by root 2 the whole square. We get 1 by 4. We get I0 and 4 I0 is k. So we can write I1 is equal to k by 4. 4 I0 is given by k. Okay. Is it clear? Now the second part we can discuss now. Okay. We will discuss the second part. So in the second case we can see same formula I1. So here we can write I2 is equal to 4 I0 cos square 5 by 2. So corresponding to lambda, the phase difference is 2 pi. So corresponding to lambda by 2, what you will get? 2 pi this into this divided by this. So 2 pi into lambda by 2 by lambda. So you will get it as pi. So we got the phase angle as pi. Now you can substitute here. So I2 is equal to 4 I0 is given by k. So k into, here also you can substitute like that directly. Okay, k into like that you can do. Okay, k into cos square pi by 2. No, by phase angle is 5. Or we can write k into cos pi by 2 the whole square. And cos pi by 2 is 0. So we got the intensity as 0. Okay, is it clear? And now we will discuss the problems related to Young's double slit experiment some more. Okay. So before discussing that problem, here once again you can see that those who are who cannot understand that one, once again we can see that one, how we got that phase angle. So we have written the formula I2 is equal to 4 I0 cos square 5 by 2. Then corresponding to lambda, the phase difference is 2 pi. Corresponding to lambda by 2, the phase difference is given by 2 pi into lambda by 2. This into this by this. So 2 pi into lambda by 2 by lambda. Lambda will get cancelled, 2 will get cancelled, we get pi. So phi is equal to pi. And already we have seen 4 I0 is given by k, that we can substitute here. It is given k units. Okay, cos square pi by 2. Then cos pi by 2 is 0. Cos 90 is 0. So if you substitute, you can see that intensity is 0. Okay, is it clear? And now we will discuss the next problem. In Young's double slit experiment, the two parallel slits are made 1 millimeter apart and a screen is placed 1 meter away. Find the fringe width when the light of wavelength 600 nanometer is used. Okay. So already we discussed in the previous video, the expression for fringe width is given by beta is equal to lambda into capital D by small d. And what is lambda? Lambda is the wavelength of light. It is given 600 nanometer. Nanometer should be converted into meter. So 600 into 10 raised to minus 9 meter. Okay. Wavelength given. Down. Then what else given? Two parallel slits are separated 1 millimeter apart. So what is that? It is small line. Distance between two slits. That is given 10 raised to minus 3 meter. 1 millimeter, which is equal to 10 raised to minus 3 meter. And the distance between screen, but it is 1 meter. So capital D is 1 meter. Now we have to find fringe width. So beta is equal to lambda is 600 into 10 raised to minus 9 into capital D is 1 divided by 10 raised to minus 3. Okay. So what you will get? Beta is equal to 600 into 10 raised to minus 6, or we can write beta is equal to 0.6 into 10 raised to minus 3 or 0.6 millimeter. So you can see that the fringe width is very small, in the range of millimeter range, 0.6 millimeter. Okay. So when you are solving problems related to fringe width, what you have to do? You have to remember this formula, beta is equal to lambda d by d. Normally students, they used to make confusion regarding capital D and small d. Small d is the, what is small d? Small d is the, is small d. So what it indicates? The distance between the two slits, that is smaller. And capital D is the distance between the slits and the screen. Okay, is it clear? And now we'll discuss the next problem. The fringe width. The fringe width in Young's double slit interference pattern is 2.4 into 10 raised to minus 4 meter when red light of 6400 angstrom is used. By how much it will change if blue light of wavelength 4000 angstrom is used? So here we can assume that all other parameters remain same because it is only given that wavelength of light only changed. Okay. So in the first case we can write fringe width beta, we are writing beta 1 is equal to lambda 1 into capital D by small d. Capital D and small d remain same in both cases, and beta 2 is equal to lambda 2 capital D by small d. So you can divide. Why we are writing like this? Because only wavelength of light is changed. Distance between slits and distance between the slit and screen remain same in both cases. So beta 2 by beta 1 is equal to, what you will get? Beta 2 is, this d by d will get cancelled. We can write lambda 2 by lambda 1. But you have to find beta 2. So beta 2 is equal to beta 1 into lambda 2 by lambda 1. So initially what is the fringe width? Beta 1 it is given 2.4 into 10 raised to minus 4. Lambda 2 it is given 4000 angstrom. It should be converted into meters. 4000 into 10 raised to minus 10 divided by 6400 into 10 raised to minus 10. So here we are writing beta 2 is equal to beta 1 into lambda 2 by lambda 1. How we are writing? Beta 2 by beta 1 is equal to lambda 2 by lambda 1 by dividing equation 2 by equation 1. And beta 2 we have to find when we are using 4000 angstrom light. What is the fringe width? So beta 1 is given, lambda 2 is given, already we substituted, and lambda 1 is given, 1 angstrom is equal to 10 raised to minus 10 meters. Okay. So we can divide it by 8. 5 8s are 40. Here if you divide it by 8, what you will get? 8 8s are 64. And you can write it as 0.3. What you will get? Beta 2 is equal to 0.3 into 5 into 10 raised to minus 4, or you can write it as 1.5 into 10 raised to minus 4, or we can write 0.15 millimeter. So this is the 0.15 millimeter. This is the fringe width when we are replacing the 6000 angstrom light by 4000 angstrom light by remaining the distance between the slits and slit and screen remains the same. Okay. Now we will proceed to the next problem. In a two-slit experiment with monochromatic light, fringes are obtained on a screen placed at some distance d from the slits. If the screen is moved 5 into 10 raised to minus 2 meter towards the slits, the change in fringe width is 3 into 10 raised to minus 5 meter. If the distance between the slits is 10 raised to minus 3 meter, calculate the wavelength of light used. Okay. So in the first case, we can write, let beta is the fringe width. So beta is equal to lambda into capital D by small d. In the second case, what happens when it is moved some distance? So that new fringe width, beta dash is equal to lambda into capital D dash divided by d. In that case also, distance between the slits remains same. Okay. Is it clear? Okay. So beta minus beta dash, the difference, no? So we can write 1 minus 2 if we are writing, but you will get beta minus beta dash is equal to lambda into d minus d dash by d. Beta minus beta dash is equal to lambda into lambda by d can be taken common, d minus d dash. Now what is given? Difference. The change in fringe width is given 3 into 10 raised to minus 5, which means beta minus beta dash is given 3 into 10 raised to minus 5. Then d minus d dash, when it is moved towards, means that difference is given 5 into 10 raised to minus 2 meter. D minus d dash is equal to 5 into 10 raised to minus 2 meter. And small d is already given 10 raised to minus 3 meter. You have to find lambda. So you can write lambda is equal to beta minus beta dash into small d divided by d minus d dash. Okay. Or we can write lambda is equal to beta minus beta dash is 3 into 10 raised to minus 5. Small d is 10 raised to minus 3 and d minus d dash is 5 into 10 raised to minus 2. So 3 into 10 raised to minus 5 into, in this formula we are substituting. Okay. 3 into 10 raised to minus 5 into small d. What is small d? 10 raised to minus 3 divided by d minus d dash is 5 into 10 raised to minus 2. So 3 by 5 can be written as 0.6. Here 10 raised to, what you will get? 0.6 into 10 raised to minus 8 by minus 2. You will get it as 10 raised to minus 6. Or you will get it as 6 into 10 raised to minus 7 meters. Or you can write 600 nanometers. Okay, is it clear? So this is the wavelength of light used. So this is the way of solving problems related to the expression for fringe width, which is given by beta is equal to lambda d by d. So here when you are solving problems based on this, you have to keep only one thing in mind. Here capital D stands for the distance between the slits and the screen, and small d is the distance between the slits, and lambda is the wavelength of light used, and beta is the fringe width. Okay. And when you are solving problems, this wavelength should be converted into, if it is given in angstrom, 1 angstrom is equal to 10 raised to minus 10 meters, and if it is given in nanometers, you have to convert 1 nanometer into meters, which is given by 10 raised to minus 9 meter. Okay. And sometimes they may give problems like this if it is immersed in a liquid. That already we discussed. When it is immersed in a liquid, fringe width will be given by 1 by n times the fringe width in air. Okay. So today we discussed some problems related to interference of light for constructive and destructive interference, and already we discussed some problems related to Young's double slit experiment. Okay. So in the coming videos we will discuss some more problems. I hope all of you understood. Thank you.